I hope everyone's doing well. I'm Tommy, majoring in physics at San Jose State. I did my summer research with Hera through the program CHAMP. My summer research site was supposed to be UCLA, but it got switched to my tiny little apartment. Nevertheless, it was a pleasure working with Dr. Stephen Ferlanetto. My research topic is about measuring the neutral hydrogen regions between the stars. For starters, we understand our present-day universe pretty well. It is sort of a middle-aged universe where things are relatively calm and quiet. We also understand its near past pretty well, where things were more exciting. And we understand the universe back when it was just a DNA. However, we don't quite understand the childhood of the universe. And that's what Hera sets out to do, to understand the late childhood of the universe. In more technical terms, the era of reionization, about 13 billion years ago. Hera is an international collaboration building a radio telescope down in South Africa that is capable of achieving their goal. In my project, I dealt mostly with a computer simulation of the universe called 21CM Fast. Through the computer simulation of the universe at this portion of the sky, in principle, Hera will be able to see the yellow regions. These are neutral hydrogen atoms. The purples are ionized hydrogen atoms. When stars are born in the universe, they create light, and with enough light, these electrons will get excited and they will leave their atoms. Without these electrons, Hera won't be able to see them. So in practice, these purples are invisible. Through the era of reionization, the universe becomes more and more ionized. I was tasked to measure the typical sizes of these yellow regions so that Hera would have a rough idea of the resolution required to make out these yellow regions. And I do that by doing the following. I draw a sphere. It's really a three-dimensional simulation, and we're looking at a slice of it. Everything in this sphere, I would take the average of them. Now, I have full control of the sizes of these spheres. Notice that as we reduce the sizes of the spheres, the color starts to depend on the location of the sphere. And that's because the amount of yellow and purple that goes into the sphere starts to vary with its location. If we try to hone in on these yellow regions and continue reducing the sizes of the spheres, eventually we get full yellow spheres. Now remember, we have full control of the sizes of these spheres. And it's only when the sizes of the spheres are comparable with the typical sizes of these yellow regions is when we get full yellow spheres. From there, we can infer the typical sizes of these yellow regions. In practice, I would do this a whole bunch of times at a whole bunch of random locations, and then I would count the number of yellow spheres, and I would change the sizes of the spheres, do it all over again, change the sizes of the spheres, do it all over again, and I would get a whole bunch of data, and from that data, I would infer the typical sizes of these yellow regions. Now that we have our measuring tool, we can start messing around with different parameters in our computer simulation of the universe and see what happens. In this particular example, I'm changing the amount of light in the universe and the distance light gets to travel before being obstructed. As we turn our two knobs, we can start to see that these regions change and they go smaller and smaller and smaller. To be more specific, each of these yellow regions are about 5 million light years across. So it would take 5 million years for light to go through one of these tiny little yellow regions. The box itself is about 1 billion light years across. As we saw, the effect was not too observable at the beginning, but towards the end, the effect becomes more and more prominent. To take us home, the reason why we're interested in the late childhood of the universe is that chances are it might just give us a better understanding of how our present day universe came about. And with that, I look forward to your questions.